Hello, and today's purpose of the day is I can use the product of powers rule, I can use the power of a power rule, and I can use the power of a product rule. We'll start out with a little bit of vocabulary from the beginning of Chapter 7. Monomial. A monomial is a number, variable, or product of variables and numbers with a non-negative exponent. It cannot be connected with an addition symbol, subtraction symbol, or be divided by a variable. And a monomial is also considered a constant, and a constant is a monomial that is a real number. So any plain number, it can be a fraction, it can be a negative number, or it can just be a positive integer value. Now let's take some time and identify monomials. Determine whether each expression is a monomial. Write yes or no and explain why. Let's look at number 1, 17 minus c. This would not be a monomial because of the subtraction sign. So I will write no, no, because of the subtraction sign. And really what this would be called is this would be a binomial because it has two terms, because that subtraction sign breaks up the terms. But we can just explain by saying no because there's a subtraction sign. Okay, number 2, 8f squared g. This would be a monomial, and it satisfies all the requirements. It does not have a negative exponent, it does not have an addition symbol or a subtraction symbol, and it's not being divided by a variable. So we can say yes, and then we can just say satisfies all requirements. Okay, number 3, 3/4. This would be a monomial, and we can clarify it even further, and we can call it a constant. And again, a constant is just a number, and it can be a fraction, decimal, it can be positive, and can be negative. Okay, and 5 divided by t. No, this is not a monomial because that division of a variable. And again, to be a monomial, you can't be divided, or you can't have a variable being divided by in the denominator. Okay, the product of powers rule states that if two powers have the same base, you can add the exponents and write as one power. For example, m squared times m to the 4th, we add 2 and 4 and get m to the 6th. If a coefficient is in front of the variable, you will multiply it by any other coefficient. So that's slightly different than the exponents where we would add them. So if we look at this example here, we have 2 times 4 to give us 8, and then we have x squared and x to the 3rd that are exponents with the same base. That would give us x to the 5th. Remember, you add the exponents but multiply the coefficients. All right, let's take a look at these 3 examples. So number 1, I'm going to multiply 7 and 9 and get 63. R to the 9th and R to the 5th give me R to the 14th. And S to the 6th and S to the 4th give me S to the 10th. Okay, number 2, negative 4 times 6 is negative 24. R to the 1st here and R to the 5th give me R to the 6th. X to the 2nd give me X to the 4th, and T cubed and T give me T to the 4th. And again, if there's no exponent with a variable, you assume that that's 1. It's just one variable. Okay, last one here. 5 times 12 is 60. A to the 13th, B to the 16th, C to the 10th, and D to the 8th. Okay, now let's break down the power of a power rule, and let's simplify here. So I see a number to an exponent, to an exponent, to another exponent. So what we can do is all the exponents here, we can start on the outside and work our way in. So I have 4 times 2, that's 4 times 2 is really 8. 8 times 2 there is 16. So this really is 2 to the 16th, and if we simplify that, if we type that into our calculator, we get 65,536. So again, we can start on the outside and work our way in to make this simpler, less clicks on the calculator. 3 times 2 is 6, 6 times 2 is 12, so this is really 4 to the 12th, which is 16,777,216. So again, that was the power of a power rule. Now if we look at the power of a product, what happens if you have more than one variable in the parentheses? Well, we want to distribute the exponent to every term inside the parentheses and simplify. So here, starting out with an example, a simpler example, here I'm going to distribute that 3 to everything inside the parentheses. And now when it's power to a power, you multiply, similar to what we did on the last slide. So this would be x to the 6th, y to the 9th. So different than before when we had exponents with the same base and we were multiplying them together, we would add the exponents, but here power of a product means that when we distribute, we multiply the exponents. So let's look at a few examples and reminders to distribute the exponent to each term inside the parentheses. Simplify each term, and we'll write our answer as one term. So let's look at number 1 here. I'm going to look at the 3 and 2, change that to a 6th, and now the 6th distributes to everything inside the parentheses. And as a reminder, if we have a coefficient in front of any variables, and now this is a coefficient to an exponent here, that is 3 to the 6th power, a to the 6th, and b to the 12th. And if we simplify a step further, 3 to the 6th is 729, a to the 6th, b to the 12th. Let's take a look at number 2. Here I need to distribute the exponent 2 to everything inside the parentheses, which means to my numerator of my fraction, to the denominator of my fraction, and to anything else that's in the parentheses. And this will give me 1 squared over 2 squared w to the 6th. Okay, then that takes care of the first set of parentheses, and here the second set I have 6 squared and w to the 8th. And now I'm going to simplify a step further, and 1 squared is really just 1, but 2 squared is 4 times w to the 6th, and then over here, so this is all times 36 w to the 8th. So now I have to combine my coefficients here of 1/4 times 36, and that gives me 9. And w to the 6th and w to the 8th give me w to the 14th. And that would be my final answer for example 2. Okay, now we will take a look at an application problem. So express the area of the triangle as a monomial. So we first have to remember what's the formula for area of a triangle. Base times height divided by 2, or 1/2 base times height. So let's take the base and the height and let's multiply them together and then divide by 2. So I have 8c to the 7th d cubed times 3c to the 4th d to the 9th all over 2. So let's here combine our numerators and simplify that. So I have 8 times 3, which is 24. C to the 7th and c to the 4th is c to the 11th. D cubed and d to the 9th is d to the 12th, all over 2. Now what do you think we get for our final answer? Do we take everything in the numerator and divide it by 2? Or what are we allowed to do here when we have the division of 2? Yes, we are allowed to combine the 24 and the 2 because those are numbers. So this 2 doesn't have a variable, so I'm not allowed to cut the c to the 11th or d to the 12th in half right now. We will look at taking the square root of variables at a later date, but right now we can't do anything with the variables in that division of 2. So I'm left with 12 because simplify right there, c to the 11th, d to the 12th. And this would be units squared because we are figuring out the area. Since we don't know what units they're in, we'll label it with units. Unit squared. One last thing to recap on this video is be mindful of negatives. What does negative 4 to the 3rd power equal? Well, if you write it out, negative 4 times negative 4 times negative 4. Here, if these two negatives cancel out, but I have one more right here, so my answer is negative, and 4 times 4 times 4 is 64, so it's negative 64. So just what I wanted to highlight there is if you have an odd exponent, but a negative in the parentheses, your final answer will end up negative because of the odd number of negatives that you'll have to be dealing with. Thanks for listening. Have a great day. Bye.